Title your page Electron Configurations. And as a statement to help ourselves, we would all, I think, agree in stating that this electron configurations basically gives a detail on where electrons are located. Where are your electrons at? Like the address, basically. For electrons. And it seems perplexing, it seems very complex, but it's actually quite simple. If you don't have a periodic table, there's always some up front that are made available to you. But with your periodic table in front of you, I want us to go over a couple of pieces. I need you to write down on your periodic tables a couple of things. I need you to write with these two columns kind of an S up top. I need you to write P off to the far right side, a D for this middle area, and an F down here. Right there. Now I'm going to do this for effect on mine. If you want to do this as well, you can. You may, but I'm not saying you have to. Everything over here, these two columns, are both S. All of these 6 columns are P's. That means that the 10 columns that are right through here are all D's. And both of these guys are F's at the bottom. So if I said chromium, what block is chromium in? Chromium is Cr. What block would you say it's in? SP, D, or F? The D block. How about lithium? Li. What block would that be in? The S block. Very good. Or oxygen. What block would that be in? The P block, right? So different elements are in different blocks. The next thing I need you to do, and you can lightly do this with a pen or pencil, but I need you to go ahead and bring helium into this spot right next to hydrogen. I realize helium is supposed to be over there, but it's confusing. It looks like it's in the P block, but it's actually in the S block. So we need to move helium to this location. Now, are you still with me on agreeing that potassium K is in the S block? Or that arsenic AS is in the P block? Or curium CM is in the F block? Correct? Okay. Now maybe with like something very dark, if that's possible, or with a lot of force, I need you to write down or really point that that is 1 right there. That's the number 1. It's there already, but I want you to really emphasize that. This is the number 2, the number 3, the number 4, 5, 6, and 7, like you see it. Now, do I have everyone's 100% attention? Okay. What block is lithium in? The S block, right? Specifically, it is in the 2S. Do you know where I get that 2 from? The 2 that's right there. What if I asked you about silicone? You would say it's P, but specifically it would be 3P, right? Now, do I still have everyone's attention? If I asked you for vanadium, V, you would say it's in the D block, right? Specifically what? 4D, and you're wrong. And this is like a trick of the periodic table. You would think that since this is D, this should be 4, right? D's don't follow that same rule. These follow a different rule. They start with 3. I realize that this is on row 4, but this is actually 3D that's right there. So what does that mean that the Y, what would that be? Not 5D, but 4D. Do you see how that's working? The D's actually start with 3, not the suspected 4. Cool? That means LA would be starting at what? 5D, and then 6D down here. We won't concern ourselves with all the way down on the periodic table, but I do want you to realize that the D's start at 3. Cool? So if I asked you for silver, AG, that's in the D block, correct? Specifically, what block? 4D, very good. How about sodium, Na, what block is that? 3S, very good. How about aluminum, what block? 3P, right? C3 and P. Are we set on like recognizing where elements are at? Okay. Now that's really not a map to their electrons, that's just where the last electron is. So let me show you how to write electron configurations, and let's start out small real quick. So I think the best way to teach this is by example, so let's look at some examples. And the first one I think I want to look at, very, very short one, and that is the configuration for nitrogen. First off, what's the symbol of nitrogen? Now let's count up our superscripts, our little numbers up top. What do I got there? A 2, right? And another 2. So what's my total now? 2 plus 2 is 4, plus 3 is... Okay, so this means that I have 7 electrons. And how many electrons does nitrogen have? 7. So we've done it correctly. Make sense? Let's look at a different one. Let's look at magnesium as our next example. So our next example is going to be magnesium. How many electrons does magnesium Mg have? Electrons. 12, right? If I had said valence electrons, you would have said how many? 2, but I said just total electrons, so that's 12. So I need to draw a map to get to these electrons. What should come first? We start with 1, right? So what's the first one? 1s. How many electrons do I need for my 1s? I need both of them. What's after 1s? 2s's. How many do I need from 2s? 2 of them. What's after 2s? And how many do I need from 2p? All 6 of them, right? What's after 2p? 3s would be next. And since I want to get to magnesium, I don't need just one, I need my second one. Now if I count the superscripts, I'll give you just a second. Count up your superscripts and tell me what all these numbers add up to be. So you've done it correct, because that's what you're supposed to have. Good? Let's look at a different one. Let's look at cobalt. That's CO right here at 27. So I need 27 electrons. Where should I start at? Always at the beginning, so 1s, right? How many do we need from 1s? 1 and 2. What's after 1s? 2s. How many do I need there? How many? No? 2s? Just those 2, right? What comes after 2s? How many do I need from 2p? Count 6, so 2p6. What comes after 2p6? And how many do I need from 3s? Have you noticed something about the s's? What's the max number of electrons in an s? 2. What's the max number of electrons in a p? 6. After 3s2, what would come after that? I need all 6 of them, don't I? So 3p6. What's after 3p6? Yeah, need both of those, right? 4s2. And what's after that? 3d, and I need 1, 2, 3, 4, 5, 6, and 7, so 3d7. That right there is the address of all of the electrons. Count up your superscripts real quick. Do some mental math.